Transformations, so Unit 2, Lesson 1. So we got horizontal and vertical translations, Part 1, and then Part 2 we'll try to hit on Thursday. Okay, in this unit we'll develop an understanding of the effects of transformations, the reflections and stretches. So the good news is a lot of you guys kind of understand that a little bit already from Math 20, which I'm talking about with the parabolas. You kind of seen it. If you forgot it, that's okay. We're going to go over it again. Okay, all right, so translation is a transformation which slides each point of a figure the same distance in the same direction. Let me maybe highlight that. Translation, okay, is a transformation which slides each point of the figure the same distance in the same direction. So that means the whole figure is moving together. It's not being twisted, you're not flipping, you're not stretching it, you're moving the whole thing around. Okay? So compare the graphs of y equals f of x and y minus k and y equals f of x plus k. So this is the vertical translation part. So we'll just kind of do this quickly here. I think you guys understand this. If you need some more explanation, please let me know. But if x is -3, -3 squared is 9. If we want y by itself, what's y going to be? -3? Yeah, it's going to be 12, yeah. 12, I guess we're right for highlighter for this section. Okay. Yeah, -2 squared is 4, plus 3 is 7. -1 squared is 1, plus 3 is 4. 0 squared is 0, plus 3 is 3. And then it's going to mirror, right? 1 squared is 1, plus 3 is the 4 again, the 7 again, the 12 again. Okay, let's go back to the normal color here. All right, next one is +3, so now we're going to be minusing 3, so it's going to be very similar to this one, but it's just going to be the flip in terms of minusing 3. So -3 squared, 9, minus 3 is 6. -2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. -3, -2, 1, and 6. So it goes back like that again. So then when you look at these, you can see that I'm just going to go ahead and cheat a little bit because I know this one is up 3. So this one right here is going to be here. And it's going to go like this. This one right here is down 3, right? It's going to be down here. It's going to be just going right outside of it. So that's just your vertical translation. Okay, moving up and down. Okay. I'm not really sure, to be honest, why they wrote them like this. We'll be familiar with them. You know, if you add the 3 over, you see the +3. And that's what they're kind of doing. A lot of people get confused because they're like, why is the x movement opposite, but the y movement normal? People always want opposite. Okay, because the y is not being affected. Okay, the x is being squared, so it has that translation left and right to make it 0. So you kind of ask yourself for the x's, what makes the inside 0? A -3. Well, -3 is left 3, right? Okay, there's nothing that makes this 0 right now. +3 is out on its own. It's not being squared. So +3 is just simply going to move up 3 after you're done. Okay? All right, good? All right. So we already got that stuff done. Like I said, we might kind of just skim this a little bit. Time. Okay. Okay, so in the third table, y has been replaced by y plus 3. What's the effect of the placement? It goes down 3. The one above it went up 3. Okay, that's all he's asking if you want to write those in there. So this was the up 3, down 3. Okay. All right. You guys can ask questions. I know I'm pressing because of time. Okay, but I think you do know this. So, okay, use your graph calculator, graph the following. You don't really need to for these ones. These are pretty simple. These are absolute value functions. So we have our standard v. Okay, and then we have our v plus 2. What kind of translation is that going to be? Up. It's not inside the absolute value, so it's just going to be up. You're up 2, and then you have your down 3 one. Okay. The equation y equals x plus 2 can be rewritten as y minus 2 equals absolute value x. How does the placement of y minus 2 affect the graph? It moves up 2. This guy? Okay. If we rewrite the second one, okay, it's going to be, you can see it's the down 3. All right, good. We're going to fly through this page quick here. So the last part. Okay. Use the results of parts 1 and 2 to answer the following questions. You guys can help me out with these. What is the effect of the parameter k on the graph of the function f of x plus k? What's it mean by parameter? Yeah. You guys got it. Yeah, I heard you. Vertical translation. The effect of it is a vertical move. You can put vertical move, vertical translation. Okay. And then it's just of k units. Just say put k here. Okay. This is the same thing. So they're just kind of showing it's the same thing. Okay. These two forms give you the same. And we're going to see this one the most. And if you get this, you can just move it over and change to having y by itself. So I'm not entirely sure why they want to show you both parts right now, but okay. Complete the following statements. Compared to the graph y equals f of x, the graph y minus k equals f of x results in a vertical, just really kind of overstating this, translation of k units. If k is greater than 0, the graph moves up. If k is less than 0, the graph moves down. All this stuff is below your grade. You guys are probably fine with this. Okay, now we're going to take a peek at the horizontal. Okay, we're doing good on time. Good. Okay, the horizontal piece. So like we already kind of talked about, here's your horizontal piece. We're looking at f of x compared to f of x minus h. So that means, yeah, we're plugging in x minus h for x, which gives some movement. And so here's the comparison. So let me pause the video. Let me go take attendance real quick. You guys go ahead and fill out these two tables, please. All right, let's see here. What do we got? Andy, what did you get for this column? 1, 0, 1, and then, okay. Okay, good. Perfect. All right. Bob, did you get the second one? No, not yet. Cassie, you have the second one?
16, 9, 4, 1.
Okay. So you can see that kind of shows you the y didn't change, right? They're growing at the same rates, just in different spots. The thing that changed was the x values. Okay, they shifted. So you can see the zeros here and the zeros here. Okay, so, sorry, 0 here and 0 here. So I go -3 at 0, so that makes over here I have a dot -3. That's this one. And then I have the positive 3, 0, 1. And they're going to be the same type of parabolas. Okay, they're just going to be growing about the same there. Whoa. Whoa. Again, I'm just drawing mine roughly. Yours are probably better, but you can see it's got the left and right movement. Okay. So we graphed them in a second table. Okay, what's the effect on the replacement? So the x minus 3, what's the effect? What's it do? 3 units right.
Excuse interruption, but then in the students' parking lot, there is a burgundy Jeep with their lights on.
Okay. And third table. Don't worry about it. And third table, what's it moving? 3 units left. I know, guys, this is too simple, but that's good. Okay. All right, let's finish the bottom here. So for these ones, you may not be familiar with the the radical functions. Remember the radical function, radical x, if you didn't know, it goes like this. Okay? And then when you do x minus 4, it moves it like you would expect, right 4. And it's over here now, which makes sense because look, if I put 0 in here, what do I get? Negative. Can we do negatives? That's why nothing's here. Okay? That's what sets your domain. A lot of you guys are missing your domain stuff on your test still. This is what sets your domain. Okay? So this one would be left 2. So based on the graph of f of x, parts 1 and 2 describe the parameter. So we would say horizontal shift h units. Now it's important when you say opposite because see how it's minus h? So that's what makes it the opposite. Okay, horizontal. And graph moves left, graph moves right. Oops, wait, h greater than 0. Yeah, we're going to stay it that way. They like to confuse you. More, David? Okay, if your h is greater than 0, so if you have a plus 2 here, I like to go ahead and just say that this is what you see, just because a lot of people think opposite's a little bit better for them. The book likes to flip on you, which I'm not going to do. So I wrote left and right here. Okay. All right, that's it for that. And then we're just going to do a few examples here in a second. Okay, so replacements for translations. So you have your y minus k and your x minus h. So your y minus k is your vertical translation. So if you're trying to add a vertical translation, you could add a k or minus a k. Same thing for replacing a horizontal. Okay, and so here's kind of your legend. Okay, this is kind of your legend of movements. So you can just kind of keep that in your back pocket if you ever forget, if you need reference. This one though, again, this is just me. I see the h as if it's positive, that means left, right? X plus 2 means left. Okay, so I would suggest to just stay with that. Stay with me on that, okay? If you see negative, it's right, so you want to change that one.
Wait, so it's wrong?
Well, because what they do is, technically, see how it's x minus h? So if you put a minus in here, it makes it a plus. If you put a plus in here, it makes it a minus. And I don't like that extra flip, so I just rather just tell you, see it as it is, of x plus h, x minus h. Okay? If you're getting confused in that, you want some more, I can give you some more on that. But trust me, it comes up in Math 20 as well. They do the same thing with the parabolas in Math 20. Okay? They say minus, minus. Okay, let's hit the examples. All right, what happens to the graph of the function f of x if the following changes are made to its equation? Replace x with x plus 2. What happens? Nope. 2 units left. Because you replaced x with x plus 2. So it's going in the x plus 2, right? Replace y with y minus 8. So that's where you put on the other side. That's going to be up 8, right? Because you have to add the 8 over to the other side. The stuff we were talking about earlier. Describe how the graphs of the following functions relate to the graph of f of x. So this would be a right 3, up 4, left 10, up 1. Okay, so this one, if you're confused in this one, you have to add this one over, right? So it'll be over here. X plus 10 means left 10. That's already ready. Function plus 4, so up 4. This right here, minus 3, so right 3. Okay. So the example 3 here is from the very beginning. Translation says every point moves the same, right? So if we have the point 2, negative 3, I will say diploma questions. I remember I've seen more SAT questions that have diploma questions, but they love doing like, here's a point, this is how it moved, where's it at now? They love doing questions like that. So the point 2, -3 lies in the graph y equals f of x. State the coordinates of the image at the point under the following transformation. So what is this point after this move? So what happens to it? Goes down 8. And it was -3, so if I go 8 more down, -11. Good. So this point becomes 2, -11. Good. I got a lot going on for the second one, or two things. Right 7, up 5. So right 7, that means plus 7, so that's 9. Up 5 means we're at 2. So 9, 2 would be that point. Okay. All right, we're on the decline here. Thanks for toughing it out today. Good work. All right, so got this guy, and then we're on the last page of 2 examples, I think. Okay, write the equation of the image, y equals f of x after each transformation. A horizontal translation of 5 units left. Okay, so we would write that as y equals f of x plus 5. This is why we did functions first, right? Translations of 3 units up. Y equals f of x plus 3 outside because it's not affected. It's just going up and down. Plus 3. And then C, they're making sure that you understand what you're doing regardless of numbers. So if I want to go m units right, so that means that I have to go f of x. If I'm going to the right, is it a minus or a plus? Minus m, right? They're just making you make sure you know what you're doing. It's not like harder, it's just putting yourself. And then p units down, so that means minus p. All right, cool. All right, 2 more examples, then we'll get ready for the run. All right, given the graph of function y equals f of x, sketch the graph of the indicated function. Okay, so if it's going f of x minus 2, so we need to move that whole graph, what? This whole graph, just right 2. I'll just take some key points. Just take this point, take this point, take this point, take that one. So that's there, that's there, that's there, and then just redraw it. Whoops. Like that. Forget that little tail there. There you go. Okay, so there's the movement. This one's going to be left 3 and what? Down 2, right? Because we're going to minus this 2 over here. Okay, good? So let's go and do that to a couple points. So I'm going to go left 3, 1, 2, 3, down 2. Left 3, 1, 2, 3, down 2. Left 3, 1, 2, 3, down 2. Right here. 1, 2, 3, 1, 2. I'm just trying to find smooth lines that I can use. Okay. Whoop. Oh, no, it's missed. I missed that, sorry. So down 3, or left 3. Yeah, so it is going to go up something like this. Something like that. Okay. All right, perfect timing. Got the last piece here. Okay, replace notation and mapping notation. So this is just talking about the function notation of like the movement. So if you want movement to x, it's just writing in your coordinates how you're moving your x's. So that last one we just did, we moved every point left 3, so that'd be x minus 3, and down 2, right? So it'd be x minus 3, y minus 2 is how you'd write it in like a point translation. Like that's called mapping notation. You're mapping the points to that direction. Okay, so I'll show you what I'm talking about. Some of you guys are confused or worn out already. That last graph we just did was that. We moved left 3, down 2 to all points. Okay? Right. Here's the last piece talking about that, and then we're done. State the coordinates of the image of the point -3, 5 under the translated described of x minus 7, y plus 4. So it's as simple as what it looks like. X minus 7, you just put this in for x. You put this in for y. -3 minus 7, -10. 5 plus 4, 9. No problem. Okay, and that last one, x minus 6. So it says it wants the equation. Okay, so this wants the equation. Okay, so that means, excuse me, minus 6, left 6, so we're going to go f of x plus 6. And y plus 1, so we're going to go plus 1. That's how it would be. Okay? All right, good work, guys. I'll see you out there.